Okay, we're live. So let me go back to the PowerPoint. All right, so as I was saying, minimize this here. As I was saying, the last time we were here, we were discussing reduction and oxidation. And the key thing you need to remember here, I'm just doing a bit of a review here, is that oxidation takes place when an atom loses electrons, excuse me, and reduction takes place when an atom in a substance gains electrons, right? We can also define oxidation and reduction in terms of increase in oxidation number or decrease in oxidation number. So we're going to look at how do we determine the oxidation numbers for atoms in a particular substance. If you recall, we looked at this example here, the reaction between magnesium, magnesium solid and aqueous copper 2+ ions to form Mg2+ aqueous plus Cu solid. All right. And if you recall, I said that magnesium was oxidized because magnesium undergoes a transformation which involves the loss of electrons. So it loses 2 electrons. And copper 2+ undergoes a reduction because it gains 2 electrons. All right. Okay, and so this process here is oxidation, the loss of electrons, and this process here is reduction. All right. So this is a simple example we looked at, and several principles are in play here, which applies to all redox reactions. But I would say that the most important one is that the number of electrons lost must be equal to the number of electrons gained. And we're going to see that to be a very important fact to take into consideration, because we'll be looking at balancing more complex redox reactions, but that underlying principle is at play when it comes to any redox reactions. The number of electrons lost must be equal to the number of electrons gained, all right? So I think that's basically it by way of review. So some other terms we need to be introduced to. An oxidizing agent is one that causes another substance to be oxidized while it is reduced. And a reducing agent is one that causes another substance to be reduced while it is being oxidized. So going back to the previous example that we looked at here, the magnesium here would be the reducing agent because it is reducing the copper 2+ to the copper, and the copper 2+ here, sorry, the copper 2+ here is the oxidizing agent because it oxidizes the magnesium to magnesium 2+, all right? So that's another definition that you need to be aware of, okay? All right, so now we're going to get into how do we determine the oxidation number of an atom in a formula, in a compound, or even in an element. And there are several definitions of oxidation number. The one that I have here on the screen is that the oxidation of an atom would be the charge the atom would have in a molecule or an ionic compound if the electrons were completely transferred, all right? So in other words, if you have 2 atoms connected to each other by a covalent bond, but if the electrons that are shared are moved towards a more electronegative element, then the resulting charges on each of the atoms involved would be the oxidation number. And there are some rules that you have to know basically to determine the oxidation number of an atom in a compound. Bring this down here, hold on. Okay, why is this thing not responding? Okay. All right, let me go ahead. I don't know why this is still here. Okay, so the first rule is that free elements, in other words, elements that are not combined with any other elements, you can automatically assume that the oxidation number for that particular atom in the element will be 0, all right? So it doesn't matter what the element is. It could be sodium, beryllium, potassium, lead, hydrogen, which of course exists as a diatomic molecule. Same thing is true for oxygen or phosphorus, which is a polyatomic molecule. Any element by itself, not combined with any other elements, you can assume that the oxidation number of that element is equal to 0. All right, so that's the first rule. Relatively simple rule. So I don't think there's any problem understanding that. Now, when it comes to monatomic ions, right, the oxidation number is basically assumed to be equal to the charge on the ion. So in this case, if you take, for example, the lithium ion, the oxidation number of lithium is +1. If you take the iron 3 ion, the oxidation number for that atom is +3. And in the case of the oxide ion, the oxidation number is -2, all right? So that's basically the rule for determining the oxidation number of a polyatomic ion, of an atom in a polyatomic ion. I'm sorry, in a monatomic ion. All right, we're going to deal with polyatomic ions later on. I'm getting ahead of myself. So let me move on to the next rule. Now, this rule is specific to oxygen. And what this rule says is that the oxidation number of oxygen is usually -2. However, there are some certain exceptions, right? In peroxides, such as hydrogen peroxide or the peroxide ion, or any compound that contains a peroxide ion, then the oxidation number is -1, all right? So this is very important for you to realize. If the oxygen is combined with any other element, it is usually true that the oxidation number is -2. However, in peroxides, in those cases, the oxidation number of oxygen would be -1, all right? So that's rule number 3 in this list. And then rule number 4 talks about hydrogen, another specific rule, specific for a particular element, in this case, hydrogen. The oxidation number of hydrogen is +1 in most compounds, except when it is bonded to metals in binary compounds. And, you know, come to think of it, this is not 100% covering everything, but I'll leave that for the time being. In these cases, its oxidation number is -1. So basically what this is saying is that if you find hydrogen bonded to any other element, its oxidation number is usually +1, excepting in the case of binary compounds where the hydrogen is bonded to a metal. In those cases, the oxidation number is -1, all right? Okay, next rule. Again, specific to a certain group of elements. It says here that group 1A metals, the oxidation number is always +1. For group 2A metals, the oxidation number is always +2. And for fluorine, the oxidation number is always -1. And I should add, what this rule is talking about is situations where these elements are combined with other elements, all right? So if you have a group 1A metal combined with an element like chlorine, then whatever that group 1A metal is, it could be sodium, it could be potassium, it could be lithium, the oxidation number is +1. And you can give some other examples for group 2A metals and for fluorine, all right? Okay, so that's rule number 5, all right? For rule number 6, and this will become important when it comes to determining the oxidation numbers of other elements apart from the ones that we mentioned above. The sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge on the molecule or ion, all right? So basically, if you have, let me see if I can make up an example here. If you have, let's say, potassium carbonate. In fact, let me get out of this here and go to my writing pad, just to show you this example. Oh, in fact, here's the example right here. I didn't realize that I have it here. Okay, let me go back to this slide. Okay, so in the case of the bicarbonate ion, I was going to use sodium carbonate, but we can use this example right here. In the case of the bicarbonate ion, right, based on the rules that we talked about earlier, we know that the oxidation number of oxygen is -2, and the oxidation number of hydrogen is +1. And we know that the total charge is -1, right? So therefore, what this rule is saying, rule number 6, what it's saying is that the sum of the oxidation numbers of all the elements in this ion will be equal to the charge. So the way we set this up to solve for the oxidation number of carbon, We multiply -2 by 3 because there are 3 oxygen atoms. Each of them carries a -2 oxidation number. So that's why we have 3 times -2 here. And then we add 1 plus 1 because that would be the oxidation number of hydrogen. And we add that to the oxidation number of carbon, which we don't know, right? But we do know that the sum of these oxidation numbers will be equal to -1, all right? So basically all we have to do is solve for the unknown. And if we do that, you're gonna end up with carbon having an oxidation number of +4, right? Because 3 times -2 plus 1 gives you -1. So therefore, when you solve it, you're going to get carbon having an oxidation number of +4. So this is basically how you would determine the oxidation numbers of a particular atom in an ion or molecule. In this case, it's an ion, where the sum of the oxidation numbers will be equal to the charge in the case of the anion. In the case of a molecule, the sum of the oxidation numbers will be equal to 0. So let me do another example so that you get a better feel for how this is done. So let's say you're asked to find the oxidation number of chromium in this compound, K2Cr2O7, all right? So let's say you're asked to determine the oxidation number of the chromium here, all right? So in this case, we know that the oxidation number of potassium is +1 based on the rules before, because if you go back to the rules, you see that any compounds that contain a group 1A metal, its oxidation number is +1. In the case of oxygen, based on the rules that we discussed earlier, we know that the oxidation number is -2. And I'm just gonna say the oxidation number of chromium is equal to X because we don't know what that is. So the entire compound is neutral, which means that when you add up the oxidation numbers of all the elements in this compound, that should be equal to 0. So therefore, we're going to set this up because you have 2 here for the potassium. You're going to have 2 times +1 plus the oxidation number of chromium. We said it's X. There are 2 of them. So we're going to put 2X here plus 7 times the oxidation number of oxygen, which is -2. And we set that to be equal to 0. All right. So all we have to do from here is to solve for X. So this will become 2 plus 2x minus 14 is equal to 0, which means that this simplifies to 2x minus 12 equals 0, which means that 2x equals 12, which means that x equals to +6. So the oxidation number of chromium in this particular compound is +6, all right? Any questions about this example? Any questions? Okay, so moving along. Let's move on now to balancing redox equations. Now, let me warn you, this skill is one that requires a lot of practice. And I'm just going to go through an example concerning how do we go about balancing a redox equation. Now, let me just say this from the outset. You can attempt to balance redox equations in the way that we're normally accustomed to. If you remember from, I think it was chapter 3, we talk about keeping check of the atoms of both sides, on both the atoms of each element on both sides of the equation. We add coefficients and so on until we get a balanced equation. You could actually do that, but when it comes to redox reactions, that sometimes you can get bogged down into a very difficult and time-wasting exercise. So the method I'm about to describe here, in some textbooks, they call it the ion-electron method. And the best way to explain it actually is to go directly into an example. So here's an example. The oxidation of Fe2 plus to Cr3 plus by the dichromate ion. Now, let me just say that this question, to be perfectly frank, does not give you enough information because you need to know what all the products of the reaction is. So I'm going to put one of the products here. And that product would be, okay, let me see. That product would be Cr3 plus. That's one of the products, right? So there are 2 reactants in this case. One is the Fe2 plus. It will be oxidized by the dichromate ion. So these are the reactants. I'm just going to put R here and R here. And the products would be the Fe3 plus here and the chromium 3+, which is not mentioned, unfortunately, all right? So basically, the first thing I would do if given this information is that I would write an unbalanced equation for the reaction based on the information provided. So the reactants would be Fe2+ and the dichromate. So they would be on the left side. And on the right side, you'll have the products, the Fe3+ and the chromium 3+ ion, right? So this would be the unbalanced equation that you're going to start off with. Okay, the next step in this process is that you're going to separate this equation here, right, the unbalanced equation, into two half equations or half reactions, all right? So one half equation would be the oxidation half equation where the Fe2+ is converted to the Fe3+. The other half equation is the one where the dichromate is converted to the chromium 3+, which would be the reduction reaction, all right? So that's basically what you do in this step. You separate the given equation here into two half equations, right? The first one is oxidation because the charge or the oxidation number of iron increases from +2 to +3. And the second one is reduction because the oxidation number of chromium decreases from +6 to +3, all right? Remember we said that oxidation can be described or defined as the increase in oxidation number, and reduction can be defined as the decrease in the oxidation number. Okay, so that's that step. So let's move on now to step 3. It says in step 3, and this is important, that you balance the atoms, all the atoms, apart from oxygen and hydrogen in each half equation, right? So basically you won't be balancing the oxygen and hydrogen in this step, but you will be balancing all other atoms that are present, all right? So in this case here, let me move this out of the way. Okay, so in this case here, in the case of the dichromate converted to the Cr3+, you'll notice that there are two chromium atoms here indicated, but there's only one that is indicated here. So to balance the chromium atoms, we put a 2 right here in front of the Cr3+. So now the chromium atoms are balanced. Now, as far as the iron is concerned, it's already balanced because you have one iron here, one iron here. That means you don't need to make any changes, right? You can just leave that as it is, all right? Now, there are other situations where you may not be able to do that. You may need to add numbers. In fact, we're going to see another example where we need to make changes to both the oxidation and reduction half equation, all right? But in this case, the only one that needs modification is the reduction half equation because you have a 2 here for the chromium, which means that you're going to need 2 chromiums here. So that's why we have the 2 here, all right? Okay, so that's what happens in step number 3. We balance all atoms other than oxygen and hydrogen in each half equation. Okay, for the next step, it says here for the reactions and acids, we add water to balance the oxygen atoms and H+ to balance the hydrogen atoms. So we're going to do this stepwise. We're going to first balance the oxygens by adding water to the side that needs it. Now, previously, you had this going to this, where you had 7 oxygen atoms here and you had no oxygens here. So according to this step, what you do is add water, and you add enough water to this side so that you end up now with 7 oxygen atoms. So that means you need 7 water molecules here added to balance with the 7 oxygen atoms here, all right? For the second half equation, you don't need to do that because there's no oxygens involved, all right? Now, the next step, or the part 2 of step 4, is that you need to balance the hydrogen atoms by adding H+ ions to the side that needs it. So in this equation here, we had 14 hydrogen atoms and we had none here. So that means that in order to balance the hydrogen atoms, we need to add 14 hydrogen ions because we have 14 hydrogen atoms on this side. We add 14 hydrogen ions on the left side, all right? So now the equations are balanced with respect to both the oxygens and the hydrogens. Okay, so the next step is that, and this is, let me just warn you, students usually, especially when you're meeting this for the first time, they usually confuse this step here. They usually mess up on this step. So I'm going to try to be as slow and deliberate as possible so that you understand what's happening in this step. So step 5 says you're going to add electrons to one side of each half equations to balance the charges, all right? Now that is necessary because if you look at the half equations that you have so far, after balancing the oxygens, hydrogens, and any other elements, you'll notice that the charges are not balanced. So for example, if you look at this half equation here, right? You'll notice that on the left side, you have a total of 14 plus charges minus 2. So that gives you 12 plus charges here. But over here, you have 2 times plus 3 6 plus charges. There are no charges contributed by the water molecule. So there's a charge imbalance here. You have 12 plus charges on the left, and you have 6 plus charges on the right, okay? So we need to balance these half equations. And the same is true for the iron 2 plus going to the iron 3 plus, right? You have a +2 charge here, you have a +3 charge here. So how do we balance the charges? Well, we add, in this case, 1 electron to the right side of the equation, because when you add 1 electron to the right side of this equation, the total charge here becomes 3 minus 1 plus 2, and that balances with the +2 on the left side, right? So that's how we balance this half equation. So for the second half equation, remember I said, let me use this right down here. Remember I said that there's a total of 12, plus 12 charges on this side, and plus 6 charges on this side, right? So the charges are unbalanced. There's a charge imbalance here. So therefore, what do we need to do? We need to reduce this plus 12 so that is equal to plus 6. And how we do that? We add 6 electrons, because each electron carries a negative charge. So 12 minus 6 give you plus 6 on this side, which balances with the plus 6 on this side. So that's why we add 6 electrons here to the left side of that equation. Okay, so that's basically what step 5 is all about. You add charges, or I should say more specifically, you add electrons in order to reduce the higher net charge side so that the charges are equal on both sides, all right? Okay, now there's another step which is important because of something that we mentioned before. And that is that in every redox reaction, the number of electrons lost in the oxidation part is equal to the number of electrons gained. The way we have it now, we have 1 electron being lost here in the oxidation reaction and 6 electrons that is gained in the reduction reaction. So obviously, the number of electrons lost and gained here is not equal, but we need to achieve that. And how do we do that? Well, what we do in this case is that if necessary, and it is necessary in this case, we make sure that the number of electrons are equal by multiplying the half equations by the appropriate coefficients. In this case, the appropriate coefficient would be 6. You multiply 6 or multiply this half equation here by 6, right? Because by doing that, you're going to end up with 6 electrons here, which is equal to the number of 6 electrons gained here, all right? So that's what is done here, all right? So you'll notice that now we multiply this by 6, so that's 6 electrons here, and the 6 electrons here would be equal. Okay, so the next step is the step where we add both half equations, all right? So we add the 2 half equations together, and we balance the equation by inspection. Now, of course, in this case, the number of electrons on both sides must cancel because, of course, the number of electrons lost is equal to the number of electrons gained. So when we add both equations together, number of electrons here and here will cancel out. And you're going to end up with what's left. So you just write down what's left, and that would be the final answer. And this would be the redox equation for this reaction, all right? One thing I tell students to do at this stage is that you check to make sure that everything is balanced, right? Because you could have made some mistake earlier, which would result in an incorrect equation. So let's do that right here. So the first thing we're going to look at here is 14 hydrogen here, right? And we have 7 times 2, 14 hydrogens. We have 2 chromiums here, 2 chromiums here, 7 oxygens here, 7 oxygens here, 6 iron, 6 iron. And we also have to check the charges, right? We have to make sure that the charges are balanced. So that is done right here. If you look on the left side here, 14 plus charges, so that's why we have 14 times 1, minus 2, plus 6 times 12, right? If you add this up, you're going to get 24. And if you check this side, is 6 times plus 3, which is 18, plus 2 times 3, which is 6. That will also be equal to 24. So the charges are balanced as well, all right? So this is something that you should just do just to make sure that you're sure of your final answer, all right? Any questions about this? Any questions about how we go about balancing redox equations? Okay, so I think it's best we do a couple of examples, all right? So let me go back to my writing pad here. Let me clean this up. And I'm just going to put down an unbalanced equation here. So this unbalanced equation will be, okay, what should I do? Okay, MnO4 minus plus N2 to give NO3 minus plus Mn2 plus, all right? So let's say you're given this equation, right? So if you recall, the first step in this equation is that we separate this equation into two half equations. So the two half equations is going to be MnO4 minus to form Mn2 plus and N2 to form NO3 minus, all right? So that's the first step, all right? We separate the given half equation into two, or I should say the given equation into two half equations. Excuse me. Okay, so the next step, if you look at the rules, you have to make sure that the number of atoms, well, excepting for oxygen and hydrogen, the number of atoms are equal on both sides. So we balance the atoms that are not balanced in the case of, with the exception of oxygen and hydrogen. So in the case of the first half equation, you have one manganese here, you have one manganese here, so that's balanced, all right? In this case of the second half equation here, you have two nitrogens here, but you have one here. So what do? We put a coefficient of 2 here to balance the nitrogens, all right? The next step is we balance the oxygens by adding water to the side that is deficient or needs oxygen. So if we look at the first half equation here, we have 4 oxygens here, but over here we have none. So what do? We add 4 water molecules, all right? In the case of the second half equation, we have no oxygens on the left side, but we have 6 oxygens on the right. So that means that we add 6 water molecules on the left, all right? So we have balanced all the atoms. So the next step is to balance the charges. So let's start off with this half equation here. In this half equation here, we have a total of -1. Let me write it here. We have a total of -1 charges on the left side. And over here, we have a total of +2 charges on the right side. So the question now becomes, how do we balance, hold on, let me check this here. How do we balance the charges? Well, we have to make sure, no, there's something that is off here. I'm not sure what it is. Oh, okay, it's fine. So basically, to balance the charges, we have to make sure that we add electrons to the side which has a higher net charge, which would be that side right there. So basically what we do is that we add 3 electrons to this side because 2 minus 3 gives you -1, so the charges are balanced. So that's how we balance the charges in the case of the first half equation. In the case of the second half equation, we have -1 here, and we have 0 here. So the question now becomes, to which side do we add electrons and how many do we add? And, oh shoot, I realized, okay, I knew I made a mistake somewhere. My apologies. So let me clean up this here. What I should have done, I skipped a step. What I should have done is balance the hydrogen ions first. My apologies. Okay, so after balancing the oxygens, we balance the hydrogen ions, or balance the hydrogens. We have a total of 8 hydrogens on this side. We have no hydrogens on this side. So that means we add 8 hydrogen ions on the left. In the case of the second half equation, we have no hydrogens on the right. We have 12 on the left. So that means that we add 12 hydrogen ions on the right. Okay, so that's the important step I missed. Okay, so after doing that, then we balance the charges. All right. So we balance the charges now by counting up the charges on both sides of each half equation. For the first half equation, let me just erase this here. For the first half equation, you'll notice that we have a total of 8 plus charges minus 1. So that gives you a total of plus 7 here, total on this side. And then on this side here, let me erase this here to avoid confusion. On the right side, we have a total of plus 2 charges here. So the question now becomes, to which side do we add electrons and how many? And the answer is that because this side has a higher net charge, we add the electrons to this side, and the number of electrons we would add would be 5 electrons. Because by adding 5 electrons, we reduce the net charge on this side by 5 to give you plus 2, which balances with the plus 2 on this side, all right? So that's how we balance the charges for the first half equation. For the second half equation, we have no charges on the left, and we have a total of 12 plus charges minus 2, so that gives you plus 10 on the right. So the question again becomes, to which side do we add electrons and how many? And the answer is we add 10 electrons to this side, so that by adding 10 electrons, you're reducing the net charge here to 0, which balances with the 0 on this side, all right? So now that we have balanced the charges and all the atoms, the next step we're going to perform is to add the equation, well, to make sure that the number of electrons lost and gained are the same, all right? And then we do the addition afterwards. So if you look at this situation that we have so far, we have 5 electrons here in the reduction reaction, or the reduction half reaction, and we have 10 electrons here in the oxidation half reaction. So we need to make sure that the number of electrons lost and gained are the same. And how do we do that? In this case, we simply multiply this one by 2. So when we multiply by 2, we're going to get 10 electrons here. And by the way, you have to multiply the entire equation by 2, not just the 10 electrons. So that means that this becomes 16 hydrogen ions plus 2 MnO4 minus, and that takes care of everything on the left. And then on the right, we're going to have 2 Mn2 plus 8 H2O, all right? O. So these 10 electrons will cancel out with these 10 electrons. And also, there are some other things that will cancel out. Namely, these 12 hydrogen ions will cancel out 12 of these, leaving behind 4, all right? And also, you can cancel out these 6 water molecules with 6 of these, leaving behind 2, all right? So the next step is simply to add them up and write down everything that's remaining. So that would be N2 plus 4H plus 2 MnO4 minus to give, and then on the right side, 2NO3 minus plus 2 Mn2 plus 2H2O. And that should be the final answer. But again, as I said before in the previous example, you need to check to make sure everything is balanced. So let's do that now. You have 2 nitrogens here, and we have 2 nitrogens here. So the nitrogens are balanced. We have 4 hydrogens here, and here we have 2 times 2, 4 hydrogens here, all right? We have 2 manganese here, 2 manganese here. We have 2 times 4, 8 oxygens here, and we have 2 times 3, 6, plus 2, 8 oxygens on the right side. And we have to also check to make sure that the charges are balanced. So we have plus 4, minus 2, so that gives you plus 2 on this side. And then on this side, we have minus 2, plus 4, which is equal to plus 2. So the charges are balanced as well. So therefore, that would be the correct balanced equation, all right? Okay, any questions about this example? Any questions? Okay, so let me do another example. Okay, so I'm just going to make up another example here. Let's say you're given this equation. SO4, 2 minus, plus, what shall I use here? PO3 3 minus to form S plus PO4 3 minus. Okay, let's try this one. So the first step is you separate this into two half equations. So you're gonna have S, oh, by the way, this should be S8, my bad. Okay, so we separate this into two half equations, SO4 2 minus to S8, and then PO3 3 minus to PO4 3 minus. Okay, so that's the first step. The second step is that we balance all atoms excepting oxygen and hydrogen. So that means that in this case, we need to balance the sulfur because we have 8 sulfur atoms here. So I would put an 8 here. In the case of the second half equation, you have 1 phosphorus here, 1 phosphorus here. Don't need to do anything because they're the same in terms of the number of atoms, all right? Okay, the next step is that we balance the oxygens by adding water to both half equations. So in the case of the first half equation, we have a total of 8 times 4, so that's what, 32 oxygen atoms. So we need to balance the oxygens by adding 32 water molecules to this side, all right? And then in the case of the second half equation, we have 3 oxygens here, we have 4 here, so that means we simply add 1 water molecule on the left side in this case, all right? The next step is that we balance the hydrogen ions by adding balance the hydrogen atoms by adding H plus ions to both sides. So in the case of this half equation here, we have 32 times 2, so that would give you 64 H plus ions on this side. And then in the case of the second half equation, we have 2 hydrogen atoms here, so that means we need to add 2 H plus ions on this side, all right? Okay, so the next step is that we balance the charges, all right? And again, we have to be careful about going about this step, right? So in the case of the first half equation, you have 64, let me move this aside here. You have 64 plus charges minus 16. And since I'm lazy, I'm going to pull out my calculator for this one. So 64 minus 16 gives you a total of 48 plus charges. So plus 48 charges on this side. We have no charges on this side. So that means we need to add 48 electrons here. All right. In the case of the second half equation, we have a total of minus 3 here. Here we have a total of minus 3 plus 2, so that's minus 1. All right. So that means that we need to add 3 electrons to this side. All right. Because by adding minus 3 here, hold on. Minus 2 electrons, my bad. Because by adding 2 electrons here, we're adding minus 2 charges, which gives you a total of minus 3, which balances with a minus 3 here. Okay, so the next step is that we need to make sure that the total number of electrons gained in the reduction half equation is equal to the total number of electrons lost in the oxidation reaction. Which means, in this case here, because we have 48 electrons here, and we have 2 here, we need to multiply this by 24. So we're going to end up with 24 H2O plus 24 PO3, 3 minus, to give 24 PO4, 3 minus, plus 48 H plus 48 electrons, all right? So this is what we get when we multiply this equation here by 24, all right? Now what I'm going to do here is erase this equation here to avoid confusion. We don't need it anymore. So let me erase it here. And basically what we're going to do is add the 2 balanced equation, half reactions or half equations to get the final answer. So basically what we're going to do is add this equation to this equation, all right? So basically we have to, of course, cancel out the 48 electrons here and here. Also, these 32 water, well, these 24 water molecules here will cancel out 24 of these, leaving behind 8. And these 48 hydrogen ions here will cancel 48 from this. So 64 minus 48 gives you 16. So you're gonna have 16 here. And I think that's basically all that will be canceled. So the next step is to write down what's left down here. You're gonna have 16 H plus 8 SO4 2 minus plus 24 PO3 3 minus to give S8 plus 8 H2O plus 24 PO4 3 minus. And now we need to make sure that everything is balanced, as I always recommend. So 16 hydrogens here, 16 hydrogens here, 8 sulfurs here, 8 sulfurs here. Okay, as far as the oxygens are concerned, you have 8 times 4, that's 32. Let me do my calculator here. So 32 plus, you'll notice here, we have 24 times 3. So plus 24 times 3. So according to this, we have a total of 104 oxygen atoms on this side. And then we do the same thing for the right side. So you have 8 oxygens here, and then 24 times 4. So let me do that. 24 times 4 plus 8, 104 oxygen atoms on this side. So the oxygens are balanced. All right. Let me see. The 24 phosphorus here balances the 24 phosphorus here. And as far as the charges are concerned, we have, let me just erase this here to avoid confusion. Okay, so we have 16 plus charges minus 8 times minus 2, 16, plus 24 times 3, which is 72. So 72. So this gives you a total of 72 electrons. I'm sorry, 72 charges plus charges. And in this case here, let me just mark this out. We have 24 times minus 3, so that's plus 72 charges. So the charges are balanced as well. So this equation here is going to be the final balanced equation for this reaction. Okay, any questions about this particular example? Any questions? Okay, so now I've done like what, 3 examples. So now we're going to see if you can do this, a problem like this. So let me take this out. And I'm going to put another example up here. Okay, so this example will be, let me see here. NO3 minus to give MnO4 minus. Oh, let me not do that. I'm trying to find one that will be a bit challenging. MN2O7. Let me try that. Let me see if that is a valid. Okay, yeah, that can work. Reacting with, okay, let me change this to N2. To form NO4 MnO3 minus plus MnO2. Okay, so let's work with this one. Okay, so what's the first step in this process? Anybody? Feel free to look back on your notes as your guidance.
We need to add some H2O to the right side.
Nope. You're jumping several steps ahead.
We need to make the Mn go into the product of the other Mn, as we have the N go into the product of the other N.
All right, so in other words, we're separating into two half equations, right? So
Right.
Mn2O7 to form MnO2, right? And N2 to form NO3 minus. Okay, very good. That's the first step. So what's the next step?
Balancing.
Balancing what specifically?
The MnO2 on the right to the MnO7 on the left.
Well, it's Mn2O7. Okay. So how do you balance that? How do you balance the manganese?
You need a 2 on the right side.
Right, you need a 2 in front of the MnO2 on the right side. Okay. What about the second half equation?
You need a 2 on the right side as well.
Exactly. Okay, very good. Because you have 2 nitrogens here, that means you need a 2 in front of the NO3 minus here. Okay, very good. What's the next step?
Balancing the oxygen.
Balance the oxygens. And how do we do that?
Well, for the first one, there's 7 on the right side. So on the left, you should do like a 5 H2O.
No, there's 7 on the left. So you put
Yeah.
a 5.
On the right, you have a 5 H2O.
Right, exactly. Okay, very good, right? There are 7 oxygens here, there are 2 here. So in order to make sure that the oxygens are balanced, you need to add 5 water molecules on the right, and now we have 7 oxygens on both sides. Okay, what about the second half equation?
You need a 3 H2O on the left.
I knew somebody was going to say that. That's not right.
A 6 H2O.
6. There's a
Oh,
2 here, right? So that means you're going to need 6 H2O here to balance with the 6 oxygen. 2 times 3, 6 oxygens on the right. Okay, what's the next step?
Place electrons on.
Nope, you're skipping a step. You're skipping. In fact, I made the same mistake in one of the examples. I skipped a step. What step is that? Oh, by the way, hold on. No, you're right, actually. Come on, hold on. Let me...
Don't we need to balance the charges?
We need to balance the charges. No, this thing is weird because okay, I think I made a mistake in creating this example here because there's no charges in the second half equation, and that's weird. Ah, let me see here. Hold on. Mn2O7, and that's MnO2. Okay, I think I have to stop at this one because there are no charges present in the second half equation, so there's no charges to balance. So this is my fault. I screwed up in terms of creating this example here. So we have to reset. I apologize and come up with a new, better example. Okay. I'm not good at creating questions, as you can see, so forgive me. Let me try this one, MnO4 minus. Okay. Cr3 plus to give Cr2O7, 2 minus plus H2O. Okay. Let me make sure I'm doing the right thing this time. Oh no, see, I made a mistake already. This should be Mn2 plus. Okay. Okay, so let's work with this one. I'm quite sure this one will work out. So what's the first step again?
Make two equations.
Mm-hmm. So 1/2 equation would be what?
Let Mn,
MnO4 minus to form
Mn2 plus,
Mn2 plus. Okay, very good. And then the other one obviously would be Cr3 plus to form Cr2O7, 2 minus. Okay, very good. What's the next step?
you need a 2 on the right side of or the left side of the CR.
I'm sorry, repeat that.
You need a 2 on the left side of the CR.
Oh, you mean for the
Balance
second
it.
equation, right? You need a 2
Yeah.
here, right? To
Yeah.
balance the chromiums, right? We don't need to do anything for the manganese because it's the same on both sides, right?
Right.
Yeah.
Okay, next step.
You need a 4H2O
Where?
on the top, the magnesium one,
To the left or right?
the right.
Okay, so 4 water molecules here. And what about the second half equations?
Uh, 7H2O.
And I need 7 water molecules on the left for the second half equation. Very good. Okay. What's the next step?
Is this where you balance the charges?
Okay, so to balance the charges, how would you balance the charges for the first half equation?
You add an electron.
Whoa, stick a pin. We need to balance the hydrogen ions first. We have 4 hydrogen, we have 4 times 8 hydrogens here. So what do we need to decide? What do we need to do to decide in order to balance the 8 hydrogen atoms?
Put 8 hydrogen.
8 hydrogen ions. And we have 14 hydrogen atoms here. So what do we need to do to decide right here?
14 hydrogen.
14 hydrogen ions. Very good. Right. So now we can balance the charges. So how do we balance the charges for the first half equation here? How many charges do we have total on the left side for the first half equation?
0.
Nope. We have 8 plus charges here. And then we have a -1 charge here on the left side. So that would be a total of what?
7.
We have 8 plus charges here, and we have 1 minus charge here on the left side. So what's the total charge on this side?
7.
Plus 7, exactly. And here we have a +2 here, and we have no charges for the water. So therefore, the total charge on the right side is going to be +2, right? So we have +7 on the left, and we have +2 on the right. So to which side would we add electrons and how many?
We would add 5 to the right.
Exactly. You'd add 5 electrons On the right, because by adding 5 electrons, you're reducing this side to +2, which balances with the +2 on the left, all right? Okay, we're going to do the same thing for the second half equation. So what's the total charge on the left side for the second half equation?
6. What's it?
+6, very good. What's the total charge on the right side of that equation, that half equation?
+12.
+12, very good. So how would you balance the charges in this case?
How did you
You
get
need-
12? 2 times 7 with 2 electrons?
No, you have a -2 here,
Yeah.
and then you have 14 plus charges. So
Okay.
14 minus 2 gives you a total of +12.
And then the 2 times 3 on the left side would give you 6.
Exactly, exactly.
Okay.
Okay, so we have +6 on the left, +12 on the right. So to which side would you add electrons and how many?
To the right. And
Right, how many would you add to the right?
6.
6 electrons, very good. And you do that because by adding 6 electrons, you're adding 6 negative charges, which gives you a total of +6, which balances with a +6 on the left. Okay, so since we have balanced all the atoms and all the charges, then what we're going to do is make sure that the number of electrons lost and gained are the same. Let me erase this right here to avoid confusion, because we're going to need a space. Okay, so what do you propose we do next in order to make sure that the number of electrons lost and gained are the same? Now, please note, you have 5 electrons being gained in this half equation, and we have 6 electrons being lost in this half equation, right? We have to ensure that the number of electrons gained in the first equation is equal to the number of electrons lost in the second equation. So what do you propose we do in the next step? Anybody?
Multiply by 2 on your second.
Okay, why would you're saying multiply by 2? Why would you
No,
do it?
no.
Oh, okay. Anybody else? Remember the goal of this exercise.
We multiply the left side by 6, the entire thing by
Okay,
6,
so
correct?
yeah, you multiply this equation here by 6. So let's do that. So 6 times 5 gives you 30 electrons, right? Plus 6 times 8, that's 48 hydrogen ions, plus 6 manganate permanganate ions. And then on the right side, we have 6 Mn2 plus 6 4 is 24 H2O. Okay, so I would agree with that. But what would you do with the next equation, the next half equation? What would you multiply that by?
By 5.
By 5, exactly. So when you multiply by 5, right throughout, you're going to get 5 times 7, 35 water molecules plus 10 Cr3 plus, and then you're going to get 5 Cr2O7 2 minus, plus 5 times 14, that gives you what, 70? H plus 30 electrons. Okay, and then the next step is what? Anybody?
Where did you get 35 H2O?
Because we multiply this 7 here, we're multiplying everything by 5. So 5 times 7 gives you 35 here. 5 times 2 gives you 10 here. 5 times 1 gives you 5 here. 5 times 14 gives you 70. And 5 times 6 gives you 30 electrons. So this 35 here comes about as a result of multiplying the 7 by 5.
Okay, so you multiplied that whole
The entire equation, exactly.
equation.
Yeah.
Okay. Well, now you would start crossing out your H2Os and your
Well, the electrons will cancel out. That's for sure, right?
yes.
And then now you mentioned the water, right? We have 24 here and we have 35 here, right? So that means that all of this would cancel out and you're going to be left with here 35 minus 24. That gives you what, 11?
11 H2O.
Okay. Anything else that can be canceled out?
The hydrogen.
Okay, so you're right. These 48 here will cancel out. These 48 here will be canceled out by 48 of these. So 70 minus 48 gives you 22. So 22 here, right? And now, I hope I can fit this down here. We can just simply add both equations and write down what's left. So 11 water molecules down here, plus 10 Cr3 plus, plus 6 MnO4 minus, to give 6 Mn2 plus 5 dichromate plus 22H plus. And again, we need to check to make sure that everything is balanced. So let's do that now. We have 22 hydrogens here, which balances with the 22 hydrogens here. We have 10 chromiums here, which balances with the 5 times 2, 10 chromiums here. We have 6 manganese here, 6 manganese here. As far as the oxygens are concerned, we have 11 plus 24, 6 times 4, 24. So 24 plus 11 gives you 35 oxygens. And we have 5 times 7, 35 oxygens. So the oxygens are balanced. And then we look at the charges. So here we have a total of 10 times plus 3, 30 charges, minus 6. So that gives you a total of 24 plus charges. And then let's see what we have here. We have 6 times 2, 12 plus charges, minus 10, plus 22. Okay, something is wrong with the charges. Let me see this again. 6 times 12, 6 times 2 gives you 12. Minus 10. Oh, okay. I know I made a mistake. Plus 22. Okay, so the charges are balanced as well. 24 charges, 24 plus charges on both sides. Okay, so that's this particular example. Any questions about this? Any questions? Okay, so I want to do one more example. In fact, what I'm going to do is let you tell me what to write down. I won't help you at all in this one. So let me start off with, okay, let me see here. Let's see. And 2 to give. Make sure I'm doing this right. I don't want to make another mistake. Let me see here. 4x minus 12 gives you minus 2. So that would be x minus 6 equal minus 1. X equal to plus 5. So let me make a correction here. Oh, actually, this one should work. Okay, so 2 NO2 minus. Let me see. I just want to make sure I'm giving you a viable problem. Oh, this should be 2 minus. Okay, hold on. So 2x minus 6 equal minus 2, x minus 5 equal to minus 1. So x will be equal to 5 minus 1 equals to plus 4. In this case, it's 4x minus 12 equals to minus 2. X minus 6 equals to minus 1. So x will be equal to minus 1 plus 6 equals to plus 5. Okay, so this would be the first. Let me erase this here. Hold on. Hold on. Plus 5. Okay, yeah, so this should work. Okay, so let me erase all this crap here. Okay, so first step, anybody? What will be the first step?
Making two equations.
I'm sorry?
You need making two equations.
Okay, so what will be the first half equation?
S2 O3 2 minus,
Mhm.
and then the S4 O6 2 minus.
Okay, very good. And the next half equation obviously will be NO2. I'm sorry, N2. What am I saying? N2 to form NO2 minus. All right. So the next step is what?
Add a 2 to the S2O3.
Okay. What else?
And add a 2 to the NO2 minus.
Okay. And then what's the next step?
Add an O2 to the left side of N2.
Add O2.
No.
2H2O.
Exactly. Add 2 water molecules to the left side. Okay. And of course, you don't need to do anything to the first equation here because the oxygens are balanced already, right? So what's the next step?
You need a hydrogen on the right side. So 2H.
How many?
2.
Hmm?
Oh, wait, never mind. 4.
4, exactly. 4 hydrogen ions on the right side. Okay, next step.
balancing the electrons,
Okay,
the
hold on.
charges.
Hold on. I think I made a mistake in this problem. Oh gosh, I keep screwing up these. Let me see here. I keep screwing up these. I'm sorry, folks. I don't know why I keep screwing up. I should have, okay. I need to switch the nitrogen here with the nitrite over here. So we have to start over again. I'm sorry. Let me take all of this out. And what I'm going to do here is, oops. I'm going to put NO2 minus here. I'm sorry about this, folks. That's totally my fault. And I'm going to put the N2 here. So this should work. Okay, so we're going to start over again, no problem. So we separate into two half equations. S2O3, 2 minus to form S4O6, 2 minus. And we have NO2 minus here and N2 here, all right? And as somebody correctly said, we need to balance the oxygens by putting, in this case, 2 water molecules on the right. Okay, and we need to put a 2 here. Okay, so let's go from this point here onwards, right? So what do you think we need to do here for this half equation here at this stage? What's the total?
You need 2 electrons on the left side.
Yes, 2 electrons on the left side. Well, actually, no. Because you'll notice that you have 2 times minus 2 gives you minus 4. And here we have minus 2 on this side. So we need to add 2 electrons here on the right side. You see what I'm saying? Because when you add 2 electrons here,
yeah.
this will be
Okay.
reduced to minus 4. All right? Okay, what about this half equation, the second half equation? To which side would we add electrons? Well, hold on. We need to balance the hydrogen ions first, right? We have 4 hydrogens here. So what do we do on this side?
4 hydrogen.
4 hydrogen ions, right? And then we need to balance the charges. So how do we balance the charges? How many charges do we have totally on the left side?
+3.
Plus 3. And we have 0 on this side. So that means what?
You need 3 electrons on the left side.
Right, we have 3 electrons on this side. So that becomes minus 3. So 3 electrons on this side. Okay. So let me erase this here. And I just realized that we're over the time, but I just want to finish this first and call it a day. So we have 2 electrons here. Hold on. We have 2 electrons here, and we have 3 electrons here. So what do you think we should do in the next step?
Multiply the first equation by 3. And
Multiply
the
this
second
by 3.
2.
Right, exactly. So let's do this first. We multiply this one by 3, we're going to get 6 S2O3, 2 minus, to give S4O6, 2 minus, plus 6 electrons. And then, as you correctly said, we multiplied this one by 2. So we're going to end up with 6 electrons plus 8H plus 2NO2 minus to give 2N2. And I just realized I made a mistake here. You know what? Let's stop here for today. We're going to pick up from this example later on, because I just realized that we didn't balance the nitrogens here and here. All right, so we'll call it a day. I'll see you guys on Tuesday. Please remember that you have the test, which is due, when is it due?
13th,
Which would be
Saturday.
Right. And I think also quiz number 2 is also due on the same day, right?
Yes.
Okay, good. So make sure you have those submitted, meeting those deadlines, all right? And we'll meet again on Tuesday, okay?
All right, sounds.
I'm sorry?
Nothing.
Yeah, so there are no questions concerning this, or well, we don't have time anyway. So I'll see you guys on Tuesday, and I have office hours later on today if you have any questions. Today from 11 to 5. So feel free to call me during that time if you have any questions, all right? Okay, so until next time, take care. Have a good weekend.